So in this video, I would like to talk about memory management in Java. And you would be asking yourself, what is memory management? And memory management is how stuff is stored under the hoods. So when you write int x equals 1 or set the value of a string, what is actually happening under the hoods? And there's two main parts of memory management, and that's the stack and the heap. In this video, I'll cover the stack. So let's write that all down here. Let's write Java memory management, and let's write the stack. Okay, so you may have heard of the data structure stack, but in case not, let's review real quick. So a stack is a last in, first out data structure. So that means that the last item that you add to the stack will be the first one that you'd remove from a stack. So let's go through an example. So let's just say, here's your stack. And let's say you add item 1 to it, and let's just call this item A. That'll go on the very bottom of the stack. Almost like if you just put a sheet of paper on top of a desk. And now, let's say you want to add another item to the stack, and let's just call that item B. That will go on top of item A. So just like if you have a stack of books, or a stack of papers, or a stack of anything else. Okay, perfect. And now, so these are like push operations, and push operations is just the term that's typically used for when you add to a stack. And then if you wanted to remove something from the stack, or pop it off from the stack, you would remove it off the top. So I'm just going to write, here I'm just going to write add to the stack. And then now, removing from the stack, you would never remove something from the bottom of a stack just because it's more difficult. It's much easier to just remove off the top of the stack. So that's why it's called a last in, first out data structure, because this item B was the last item on to the stack, and it's going to be the first one you remove. So then after you removed item B, then you can remove item A, and then you can end up with an empty stack. Okay. So now how does this relate to Java memory management? And that's because there's something called the call stack. And this is where method invocations and local variables live. Okay, so as you may have heard, every single Java program, whether ever written, always begins with the main method. So I'm just going to write main right here to represent that. And what happens underneath the hood, actually, is that there's a stack that holds these method invocations. And just as if you might add a sheet of paper to the bottom of a stack, this main method will get added to the bottom of the stack. So we can write main right there. And now let's just say this main method calls this method called foo. And let's write foo up here. That method foo will get placed on top of the stack. And it's going to get placed on top of the stack just like book B up here was placed on top of A. So let's draw that. Main and foo. Okay, perfect. And so it's got the main method invocation, and then on top of that, it's got the foo method invocation. But the stack actually holds two things. It holds method invocations. So let me just write that here, method invocations. But it also holds local variables. So let's write local variables. Okay, perfect. And to illustrate how local variables are stored in the call stack, let's say within this method right here, let's say there's this variable declared right there. That variable in x equals 1 will get placed in the foo method invocation in the stack. So that will get placed right here, that method, that variable. So main actually would not, this main method would not have access to that variable defined in this foo method. So if down here, if I wrote something like system.out.println, and I'm just going to write println for short, x, it's going to throw an error because x isn't defined in here. So so now when foo returns, it's going to get popped off the stack. So you'll end up with main once foo returns, and then when main returns, your program will end and the stack will be empty. So this might be a lot to take in right now, so I created an example to illustrate this. Okay, so here we are in Eclipse, and we've got this example that I came up with. So main function is obviously the first one, the method that will start your program, and this method will get put on top of the call stack like we talked about, and then foo will get put on top of the main method, and then when this method calls bar will get placed on top of that. So let's take a look at this. I set a breakpoint right there. So I'm going to debug this. Okay, perfect. So now we're right here in this program execution, and we can actually see the call stack right here. So at the very top of the call stack is the function where we're at, the last function to be added to the call stack, and that's bar. And as you can see the local variables to this part of the call stack. So you can see s is equal to 10. But if you were to go to the different part of the call stack by clicking here, you couldn't see that variable anymore, but you can see the variable x equals 3, which is defined right here in foo. So let's go back here and let's watch method invocations get popped off the call stack. So if I were to do step over and push this button right here, then we just return from that function, and now bar is no longer on top of the call stack, and foo is. And now if we're to continue execution of the program, then foo will get popped off the call stack, and then this line will be removed, and then we'll be in main. So let's see that one more time. Okay, beautiful. So foo was just popped off the call stack after I pushed that. And now if I were to continue one more time, then our program completed. Exit value equals 0. So thanks for watching this. I hope you learned a lot.